Okay, guys, good morning. Looks like Blackboard's having some major problems this morning, and it's taking a long time to join the session. I'm recording the session as usual, so I'll put up an announcement if people have trouble joining. They can view the recorded session later. So the plan for today is I'm going to do an instructor demo here. This won't take too long, of the 7.4.1 integrated lab for DHCP and NAT. And as an alternative to the three, there's three other labs that do all these separate subjects, but I think it'd be easier for you guys to do just the one lab. Okay, I'm going to go and focus in on some of these screens here and cover some of this material. Okay, so as a reminder, please evaluate your classes from the easiest way to do this for me is to go to the My TCC page for this course, and in the left-hand column, there's a link to click. I'll just pull that up so we can see this. In the left-hand column where when we pick the PowerPoint slideshows or the student lab printouts, you can click on the course evaluation, and then I'll take you straight to it. There is another way to get in there when you log into WebAdvisor, but logging into My TCC Blackboard is faster and easier in my estimation. So these labs I'm going to cover for today, this 7.4.1 lab, and it was written for in the days when the CCNA certification, we had already covered OSPF by now. So I have another document in here, the 7.4.1 configuration to use the RIP statements instead of the OSPF statements. So just a quick peek at that lab. I think I've got another tab here. I should be able to do this. There we go. This is the lab we're going to cover for today. And it's going to simulate a pretty real-world environment where R1 and R2 and those two PCs and a server represent an inside company. They want their inside server, which has their web products to buy, to be available to the outside world. But look, it's got a 192.168 type of address, and that would normally not be available in the outside world. So we're going to use the NAT function on R2 to translate that inside address to a global address, a simulated global address. And then when we ping it from the outside world, we should be able to connect to it seeing its global address instead of its untranslated inside private address. The second part of this lab is R2 is also going to be configured to be a DHCP server for those PC1s and PC2s. And we're going to use the IP helper address function so that our PC1 and PC2 will be able to pick up their IP address from that R2 server. There is a mistake in the lab procedure because it says to go to R1 and type show IP DHCP bindings. Well, R1's not the DHCP server. R2 is. So we need to change that. I'm going to go through and step through a good portion of this lab because there's so many gotchas in here that I want you guys to not have a problem with. Yeah, we only have about 3 or 4 people that have been able to join, and normally we have most of our people here by this time. And I noticed when I tried to go in as my preview user that it took me a couple of minutes for it to go in there. So it looks like it's being recorded okay, and the people that can't come and see us now, they'll be able to look, because I've been posting all the recordings of these sessions on the recorded presentation web link. Now, there was another page I wanted to show you here, which is this issue is he assumes you use OSPF. And if you roll all the way to the bottom of the lab, it does actually have the solutions for all the 3 routers to type in. But I put there in the alternative, if you don't want to bother to mess with OSPF right now, since we haven't actually covered it, we have covered RIP. So I have that second document in the files section. Is a Microsoft Word document. Oh, good, people are starting to trickle in. It's apparently taking several minutes to process users and get them in. It took me couple of minutes on my preview user to go in. A couple times it wouldn't go in at all. So in the alternative, when you do this lab, we've already covered RIP. These are the RIP statements, the RIP routing protocol statements that we're going to use for the various routers. Now, the RIP procedure is only running between R1 and R2. This is our fake internal corporate network. The router R3, the ISP router, that's the ISP router. They're not going to exchange RIP updates with us. So in the normal world, we would run RIP or OSPF within our company, within our routers. And then we would do a default static route to our ISP, so we could see those 750,000 routes that are on the backbone of the internet. And then the ISP itself would do a simple static route to point to whenever people wanted to go to our server and see our products for sale, and they would point to that. So that's what we're going to be doing here. I'm going to type in all these statements and show you how to get us up and running and make sure the DHCP is working. And then I'm going to show you a little secret thing in the lab that might save you from doing, I think it's step 8, by doing the NAT overload early in an earlier step. Okay, let's see now. What do I need to cover next? Okay, what I'm going to do now is go ahead and bring my packet tracer up here. Now I'm going to be show full screen for a second. I'm going to bring packet tracer and zoom in because it's too small to see. So here's the topology for this lab. I'm going to go ahead and drag the devices into packet tracer one at a time. I'll connect them up. I'm going to show you a couple of gotchas here. For example, I'm not going to put S1 and S2 in here because I have my packet tracer screen's kind of small. I'm going to connect these PCs straight to the Ethernet ports of the router. I'm going to use the older router so that FA0 and 1 matches the 1841 model router so that it matches exactly. And I'll show you where to find that in packet tracer. The gotcha here is that you cannot connect with these older routers. They don't have the auto MDIX feature. This means that you can't use the straight through Ethernet cable. It won't connect. So I'll show you in packet tracer where you can go in and choose the crossover cable, the dotted line connection cable, and you'll be able to connect these together and be able to work them okay. Okay, so I guess I should go ahead and here's a look at the diagram. I'm going to have to zoom away from this and zoom back to the, let's see, where my Microsoft Word document go. There it is. I'm going to zoom away from this and I'm going to zoom back to the packet tracer so it fits the whole screen because we're kind of got crammed for real estate here, and we'll start dragging devices in here and hooking them up. Okay, bring this up so I can see the lab diagram. Stop sharing the entire screen, and then we'll just share packet tracer just itself. Okay, so here's packet tracer all by its lonesome, and we're going to start putting this topology in here. So I'm going to start at the, I'm going to start at the top and kind of work down here. At the very top of the diagram, we have the router in the middle, R2. Now here's a secret thing. I'm going to do the server first. So we go to, so here's all the routers and switches. There's a secret folder. I'm going to show you in just a second. I'm going to go to the end devices. I'm going to choose a server because we're going to have a simulated inside server here. I'm going to click on that server and I'll bring it up here. Oh, it's so big and fat. I'm going to put it right up here. Oh dear, can I go up there? There we go. Okay, I'll go ahead and configure the server. This server is going to be, of course, configured within our company. I'll go to the desktop. Oh, we can't see that. Let me pull this out a little bit. I click on the desktop, and then I'll click on the IP configuration screen, which is kind of like the Windows control panel. And servers don't normally get DHCP addresses. They normally get static addresses. So this server is supposed to be 192.168.20.254. And the subnet mask is going to be, let me see, press the tab key. Oh, you posted, that's the proper subnet mask. It's a /24. Now his default gateway is that router port that is being connected to there on R2. So R2's fast Ethernet port is 192.168.20.254. 20.1. Okay, and no DNS server is required in this particular environment. Now later on when we put our DHCP environment to the two PCs, PC1, PC2, I'm going to put in a fake DNS address. I'm going to use that 9.9.9.9, the Quad 9 project, which is a good DNS server to set your real machines to, because it's kind of like blacklist bad websites that might put ransomware on your machine, as opposed to Google 8.8.8.8, who's tracking you like a dog, or your cable company's DNS server, which is if you mistype something, you get targeted advertising. So if you don't like being advertised, targeted, don't use Google, use DuckDuckGo, something like that. Okay, that should take care of the configuration of the server. We haven't connected yet, but I'll do that in a second. Okay, let's bring in the R2 router. Now here's a secret, gonzo secret insider tip of the day. Normally I would connect on network devices, and if I pick the 1841 router and brought it up here, it doesn't have any serial ports configured for it. We have to go through that process of going to the physical page and turning off the power and connecting a serial port. But they've got a couple in this folder here. See this folder right here next to the lightning bolt? I clicked on that. And there's an 1841 that already has serial ports already installed in. I'm going to drag it up there. Now let's check. I'll put this on it, and it tells me, oh good, it's already got the serial ports installed. And this is the 1841 router, which has fast F00, F01. So it matches this lab exactly. The newer labs have G00, G01. I'll go ahead and make a connection now. On the lab, on the top of the lab page, it shows the dotted line symbol. So if I use the solid copper straight through cable, that wouldn't work, because this is in the days of pre-MDIX. The 1841 router does not support auto MDIX. So that means you must use the crossover cable if you hook a server, for example, straight to a router. We're going to run into the same exact situation and issue when we hook up our PCs at the bottom of the topology. So I'm going to go over and choose the dotted line, the dash line, copper crossover cable, and I'll connect it to the Ethernet port on the switch. And then we'll choose on the router, it specifies that it connects to port F00. Okay, it's red. Well, I haven't done a shutdown on the port yet. After I do that, it'll turn green. Don't worry about that for now. Let's worry about that a little bit later. Okay, now I want to bring in my other two routers, and we'll bring in the serial ports to connect those. So back to the secret folder, and we'll drag in two more 1841s, and I have to really cram them close together here because there's not a lot of real estate on the screen that I have to share with you guys. Okay, now I'm going to go through the process of renaming these routers to be exactly what they are on the lab procedure, and then I'll make the serial connections to come up. So let's, yeah, see, it has serial ports. He's got serial ports. He's got serial ports. Oh, good. We'll be able to connect these together. We won't have to go through that provision process if you just pick the bare bones 1841. Let's see. Oh, still only about 4 people have joined now. 1, 2, 3. Okay, I've got the attendance okay here. This is so sorry about the Blackboard stuff. So, by the way, TCC is thinking about choosing a new what we call a learning management system, LMS. Blackboard is a learning management system. Many years ago, we used something called Campus Cruiser. We're looking at maybe in the next few years when our support contract runs out for Blackboard, we're going to have to choose either Blackboard Ultra, the new version of Blackboard, or maybe something like Canvas. Now, if we choose Canvas, it's going to be great for your Network and Academy guys, because Canvas is actually the LMS that Canvas Network and Academy runs, so it's going to look very familiar to you. Arlington Independent School District, for example, is running Canvas for their K-12 environment. So all the kids that are learning from home now, they're using Canvas as well. So by the time they graduate and go to Tarrant County College, they'll already be used to that LMS. Okay, I need to rename some routers here. So I'm going to go to our R1 first. I'll click on that. Let's bring this into our screen. I'll click on the config tab, and that's going to be R1. And the R2 router, the top of the triangle, the man in the middle router. Do this down so we can see it. It'll be R2. This triangle configuration of routers is almost the same on all of the Cisco labs that have 3 routers. They're normally called R1, R2, R3. In some cases, like for example in this lab, we're renaming R3 to be the internet service provider. Okay, I'll click on router R3, drag it down so it's visible, go to the configuration mode, and he is R3. Oh. Now, I'm going to go ahead and make the serial connections up between these devices. So I'm going to click on the jagged lightning bolt, and I'm going to choose the serial connection, serial DTE. You can choose either one of them, these both work. I'm just going to choose serial DTE. So click it. Okay, so S1, S00 port connects to S2's S00 port, and S2's 0001 port connects to 001 port of R3. I made a mistake. I labeled R3. It's supposed to be ISP. I should fix that. It normally would be called R3 in most of the labs. I'll call it like it's supposed to be. ISP. There we go. Now it matches the lab printout. So the ISP is your internet service provider. He's connected to the internet. He's got a big, this is $1 million router that has a border gateway protocol and 1 million routes in it. Our little $1,000 branch office routers can't handle that. We just have a few routes, a couple of dozen routes in our internal corporate structure. Okay, so I've made the connections up. They're all red right now. I haven't done any of those shutdown commands at this time. Okay, let's get our 2 host PCs in here, our 2 employee desktop type PCs. I'll click on the end user endpoints, and I'm going to kind of put them here to the side because we're running out of room. Okay, so this PC, I'm going to name it like it is. It's Clarice tells it like it is. I'm going to put it like it is. So it's PC1. I'll put PC-1. So it's styled kind of like we did before. And PC1, I'll style. I mean PC2. I'll style this at PC-2. And let's make up those connections. Again, now we have to do the same trick we did before. When we go to the connection panel, if I use straight through cables, they won't make up. They won't make the connection up because the older 1841 routers didn't have the automatic circuitry, what we call auto MDIX, that would automatically, you could use a straight through cable or a crossover cross connect cable that work either way. So we got to use the crossover cable. This is what we used to have to do in our real Cisco lab with our older machinery that didn't have auto MDIX in it. So I'll click on this and connect the Ethernet cable to, let's see, it's specified to be connected to F0. Oh, I'm sorry, I'm going to the wrong router. It's supposed to be connected to F01. Drag them over there. There we go. And PC2, I'll do the crossover cable, and I'll connect from F01 to the router's Ethernet port. There we go. Now we made those connections up, and space this out up here. Okay, now let's look at the configuration of PC1 and PC2. They're going to be DHCP clients, so we actually don't need to configure anything on them because by default, like in the real world on real Windows computers, you go to the desktop and choose the IP configuration, which is the control panel. We're going to change that to DHCP. Now, what's going to happen here is there's no DHCP server has not yet been configured. So there's a figure, I think I forgot to mention this during the lecture, is if you set a PC workstation to be a DHCP client and he doesn't get in touch with a DHCP server real soon now, he'll temporarily assume what's called a private inside IPAPA address. It's like a 169.254 address, so that at least he has some connectivity with his neighbors. He won't have any connectivity to the internet, but he could. This is something, so like if you put 5 auditors in a conference room and they don't need DHCP service, they'll still be able to communicate between themselves and share their financial files. Okay, I got to do the same thing to PC2. So I'll bring PC2 into the picture. Go to our desktop and choose the IP configuration and change it to DHCP. And eventually when we configure that DHCP server on R2, we're going to put the pass-through commands, the IP helper address commands on R1, and those PCs will be able to get their IP addresses. We'll be able to ping away from those guys. Okay, so I've taken care of putting all 3 devices and all 3 routers and all 3 host machines on there. I've connected them together. We don't apply any IP addresses to the PCs because they're DHCP clients. We've applied the static IP address to the server. So now let's go into the R1, R2, and R3 and configure some of the addresses on those. Click on R1, bring it down where it's visible, and I'll go to the CLI. I have to drag it up a little bit. Can't quite see the bottom of the screen. There we go. Okay, when I went to that config tab and I said be R1, you notice he did that for me. He did the host name R1 for me. Now, I'm just doing this as a quick setup demonstration. I'm not going to do each and every step here in the lab. I'm not going to, for example, I'm not going to do the banner message of the day or passwords or anything of that nature. I just want to go in here and do some basic configuration and get some connectivity going between these routers and get RIP working in our internal corporate network, R1, R2, and then get you started with the NAT function. Okay, so I'm going to go to R1 and assign some IP addresses to these devices. So R1 has got a serial port that goes up to R2, and it's got 2 fast Ethernet ports that are the default gateway ports for our PC1 and our PC2. So I'm just looking at the chart here that's off your screen, but I'm looking at the chart from the front page of the lab of lab 7.4.1. I'm going to go ahead and configure some of these addresses. He's already at the global configuration mode, so I'm going to say interface fast Ethernet 0/0, and the IP address of F00 is 192.168.10.1. That's going to be the IP address /24 style IP address, and I'll perform the no shutdown command. Now I'm going to go to interface F0/1, and he is 11.1 instead of 10.1. So we can give him an IP address of 192.168.11.1 and do no shut on him. So he's up and up and up now. Now let's go to the serial port that goes up from R1 to R2, where the server farm is located at. So I'll say interface S0/0/0, and the IP address is 10.1.1.1, and it's the /30 subnet mask because it's that's good to use in a point-to-point circuit where we only need 2 addresses. /30 networks are very small and only have 2 available addresses, so we don't waste a bunch of address space with it. I'll do no shutdown. He won't go up and up until I do the corresponding consistent configuration on R2's S00 port. So he won't be able to go in up and up yet. So in the real world, if you would show IP interface brief on the router, I should have it here. You would see that the Ethernet ports are up and up. And the serial port is not yet up because he's waiting for the keep alive pulses to come back from the other serial port that's on the other router. We have not configured that yet. Okay, I'm going to go ahead and go to R2 now. Notice that we're green on the Ethernet ports going to the PCs. We're cool with that. Now let's go to R2 and take care of all his reds. I'm going to click on this. Stretch him out a little bit. Bring him down so he's visible. There we go. And I'm getting a big nothing here. Okay, I'll try again. R2. Oh, I'm in the wrong screen. That's okay. My fault entirely. I wasn't at the CLI, I was back at the config. There we go. I lost my mind there for a second, but I'm okay now. All right, so we're going to go and first of all, let's do this fast Ethernet port. I'm already in the configuration mode, interface, fast Ethernet, and it's 0/0. And let's do the IP address. That's going to be the default gateway for our file server, who is going to be NATed to the outside world to a globally unique and valid outside address. Okay, R2's Ethernet address is 192.168.20.1. He's going to be the default gateway for our server. /24 type address. Open the port. Now let's take care of that 000 port going back to R1. So that R1 can come up and up on both the ports. So I'll say interface S0/0/0. And his IP address is 10.1.1.2. And the same /30. Shut down. And now let's do show IP interface brief. Okay, I'm just stacking attendance here. Just 1 second. Thank you. So I'm so sorry about all the. Looks like it's taking you guys 5 and 10 minutes to join this course and get in here. But you newcomers, sorry, I'm recording this so you can go back and get the stuff that you missed. So, oh dear, that's so. There we go. So we can see on this particular. If I bring it to the foreground, is it shown? It was working last time. So 00000 is up and up. He's talking back to 0001. So in theory, I should be able to ping pin.1.1.1. Yeah, I can ping back to R1 from R2. So we have IP connectivity between R1 and R2. Now I've got Ethernet port to go to the inside server. So I should be able to ping 192.168.20.254. And that worked fine. The first one failed because our process had to correlate the layer 2 MAC address with the layer 3 IP address. So we got good connectivity between our inside server and our R2 router. We have connectivity between R1 and R2. We're not going to be able to test the PC1 and PC2 at the bottom until we top that DHCP code in R2. And then we'll check and make sure it's working as well. Okay, let's make up the connection to the ISP. So I'm at R2, and that ISP port is 0001, and right now it has no IP address assigned. It's administratively shut down. So I'm going to go ahead and put that code in. Configure T interface serial 001 is the one that goes to the ISP, and the ISP is assigned us an address of 209.165.200.22. Oh, wait a minute. 225. Almost typed in the ISP values. Wait a minute, I'm still on R2. Okay, and that's 255.255.255.252. And I'll do no shutdown. Okay, again, that 0001 port on the right-hand side of R2 that goes down to the sort of 3 o'clock position where the ISP is. Until I go to the ISP and complete that configuration on that other serial port, he won't be able to come up and up. So everything, this is proper, everything's working as it should be. We're not running into any errors or problems yet. Okay, so you notice over here, the 2 serial ports between R1 and R2 have gone green. We have a good connection to our server, it's green. Our 2 PCs are connected at the data link layer, we got a good connection. They don't have any IP addresses yet. So if you float over them, they've got that 169.254 temporary address on those 2 routers. I mean, those two devices. They could ping each other, but no, I'm sorry, they won't be able to ping each other. They're not plugged into a switch. They're in different subnets of the router. So until we fix that, they won't be able to ping anything. Okay, so let's go to the ISP and turn on its serial port and give it that ISP address that he has got from his bank of addresses. And then we'll put some RIP in this thing and get where we get some connectivity. Let's see, what's the visibility here for you guys? There we go. Okay, it's already been named ISP. If we do a show IP interface brief at this point, I haven't assigned any IP addresses to anything here. So far as the ISP is concerned, all we care about is the 0001 port. That cloud thing in the diagram, that's all the rest of the ISP's equipment that connects to the real internet. But we just have to configure the serial port that faces us and gives us connectivity. So I'm going to go to the privilege exec mode, go to the configuration mode, and go to the interface serial 001 port. And let's assign him an IP address. So the ISP is his address. That's our That's what we're going to point to with our default gateway to get connection to the outside world. And that's 209.165.100.226 and a 255.255.252. And let's do the no shutdown on it. Oh, look at here. We got green. We've got green. Everything's green. Everything's looking copacetic with greens. Okay, so we've assigned IP addresses. Let's do a test from R2. Let's see if we can ping our ISP's address. In theory, we should be able to do that because it's a direct point-to-point serial connection. So if I look at R2 and I do a show IP interface brief, I can see that my serial port 001, 209.165 is up and up. So can I possibly ping the ISP itself? 165.200.226. Okay, I can ping them just fine. Okay, so it looks like we have base connectivity here between all our devices. We haven't done any routing protocols yet. We haven't done any static routes yet. Okay, what I'm going to do now, let me see, temporarily switch to, I want to show you this, just to review this other screen. I want to share the Microsoft Word document. So the instructions in the lab are, let's see, does the mouse work when I do this? Okay, so instead of using the, you can use, if you want to go ahead and read ahead and use the OSPF and use the final iOS listings at the back of the lab, you can use the OSPF, but you're not going to really understand, OSPF uses wildcard mask instead of subnet mask. So I'm going to demonstrate this instead. This is why I made this document. What we're going to do is create between R1 and R2. We're going to make a RIP domain using the router RIP command. And we already know about RIP. What I have to do is say router RIP. We're going to say version 2 because we have some different subnet masks here. And we're going to put in all the directly attached networks. Router R1 has got the PC1, PC2 network. Then it's got the 10 dot network that goes between the serial ports between R1 and R2. R2, we're going to turn on the router RIP process. It has the 10 dot network that goes between R1 and R2. And it has that network, 20.0 network that goes to our simulated file server. Now, default static routes. Remember that, guys? This is what you normally do in the real world. If you're a small company and you don't want multiple connections to the internet and you don't want to bother with configuring border gateway protocol, which is very complicated, it's a CCNP topic. So what we're going to do is establish a default static route from R2 to our ISP's address. We could say this by IP route 0000, which means any IP address, any subnet mask. And then we could either use the next hop address. This is the IP address of the ISP's serial port back at the ISP's facility. Or we can simply use a directly specified and point to our S001. The advantage of the second method is that when you use the first method and use the next hop address, he's got to go through the entire routing table process and look up that other address. So that's a double lookup procedure. It's more efficient to do this on a serial port if we can get away with it. So router R3 is not speaking RIP. They're using some sort of internal routing protocol within their devices that they're not going to share with us that gives us the connectivity. They're probably using ISIS, intermediate system, or something like that within their organization. So what the ISP is going to do is create a simple static route, not a default route, but a simple static route to our facility location, so that if they receive any packets that are 209.165.200.240 network with the subnet mask, that's 16 addresses, 14 usable addresses, that's the range of addresses they're selling us. They're leasing that bank of 16 or really 14 network addresses on a recurring monthly basis. And that way we'll be able to set one up as a static NAT to the server so that people in the outside world can, we can point our DNS to it. And then the other addresses we'll use as when we do the NAT function, as a bank of addresses that our employees can use to get to the outside world. Okay, so let me stop sharing that, and let's go back to our router. Go back to our packet tracer. And let's get our RIP going between our internal company and verify connectivity. And then we're going to do, after I do that, we're going to go into the DHCP function and get that DHCP server run on R2, make sure it passes through R1, and our PC1 and PC2s get connected properly. Okay, I'm going to go to route R1. Oops. Let's click in on the simulation instead of the real thing. Excuse me, I clicked on the wrong device. Click on R1. Bring it into where we can see it. Okay, I'll go to the privilege exec mode, and then I'll go to the configuration mode, and I'm going to type in those first lines in that Microsoft Word document. So we've had this before, router RIP, prompt changes to config-router, version 2, because we're using some different subnet masks, and version 2 is generally preferred over the original version of RIP because, oh, it allows classless addressing, it allows variable length subnet masking, it allows classless interdomain routing, it uses multicasting instead of broadcasting, so it's generally a little bit, quite a bit of an improvement over the original RIP. Okay, what are our directly connected networks on R1? We had the 10 dot network for our serial ports. So I'm going to say network 10.0.0.0. And then we had our 192.168.1.10 network for one of the Ethernet ports and the 20 dot network for the other ports. So I'll say network 192.168.10.0 and 20.0. Okay, that should take care of the router configuration for R1. Okay, let's skip over to R2 and give him some configuration so he can talk back and forth and establish and maintain this RIP adjacency with router R1. Slowly they trickle in here. We're getting more like the normal. We're not up to our normal level of attendance yet, but we have quite a few people that sort of see. Make sure I don't miss anybody. And I'm counting people when they're present, but when they're absent, I'm not putting the absent in there because you can get all these nasty grams. And I figured during these hard times, we don't need to be bugging you. And you know, the mainstream media is already terrorizing you enough with the picking pox thing, so I'm not going to bother you with all those nasty grams. Okay. So here we're at R2, and we need to do some router statements on this. So I'll go configure terminal. Boop. And we'll turn on the router RIP function. And we'll say version 2. Now the instructions on the lab say do not advertise that 209.165 address that goes to the ISP. That's being taken care of with static routing statements. We have a default static route to go to the ISP. They have a regular old standard static route to connect to our limited network that we have. All we're going to put in our RIP process is the 10 dot network. So I'll say network 10. And that 192.168 network that goes to our file server, 192.168.20.0. Now, I need to create a default route on router R2 that points to the ISP connection. We're not going to use RIP or ISIS or anything like that to the ISP that would consume bandwidth. So before I do that, now we could create a default route on R2 and R1. That's okay if you just have 2 or 3 routers. But normally a good practice is you create the default route only on that router that connects to your ISP, in our case, this R2. And then you use the RIP process to propagate that default route to all the other routers in your company topology. So if you had dozens or hundreds of routers, you would have to type hundreds of lines and not make any mistakes. So I'm going to go ahead and put in the command default information originate. That's going to tell this RIP process on R2 to propagate that default route back to R1. So default information originate haven't done the static route yet, but I'm gonna do that now. Okay, so I'm gonna go back to here, go to a nice clean configuration mode. And so I'm gonna type IP route and 0.0.0.0, which means any IP address, 0.0.0.0, which means any subnet mask. So any address that's on the internet would match these lines. If it's our internal corporate addresses, they will be more closely matched by the more bits rule in the routing table, because there's 24 bits that match, and they'll go within our company. So any outside internet address won't match our inside corporate addresses, so we'll be hit by this line. Now, I'm not going to use the next hop IP address version because it's a double lookup, recursive lookup. I'm simply going to say serial 0/0/1. So that command is telling this particular router when he goes through and receives any. Let's look at the routing table right now. This is an example. Show IP route. So we've got the 10 dot networks. We've got the 192.168.20 network that's directly connected on this router. We've got the 192.168.10 network from the other router. We got both the .10 and the .20 are okay here. I don't see the 11 for some reason. Did I forget to do the 11? I'll go back and check on that R1. That's missing. It should be there. We'll use R1 for the test. So this means that if a packet comes into this router and it goes to the routing table and it's not 10 dot something, it's not 192.168.10 or 11 or 20, then it would normally be dropped. But that last line, the S star, that's the static route you create on this particular device. Let's go back to R1. Let's troubleshoot this problem here. Did I forget to type something? Let's go back and check. Because the root process should have shared that with it. It has the 10. Did I mistype it? It looks like it's there. Let me do a show IP interface brief and looking for any fat fingered errors. 10.1 is there. 11.1 is there. How about show IP protocols? 10 and 20 are there. Okay. So I typed in the correct code. Maybe it's just packet tracer shenanigans and lucky business. Okay, now we need to go through the router R3 and connect and create what the ISP would create for us, because we're paying them on a monthly recurring basis to use their big fat routers. So I'm going to create a static route on the ISP pointing back to us, because we're going to have to do a test later on that from the ISP, see if we can connect to the NAT address of that file server that's over on the left-hand side of R1. So IP route 209.165.200.240 is the network address that he's leasing to us. And that's a 255.255.255.240. Bank of 16 addresses. One of them is reserved as a network address, one's a broadcast address. So that's 14 addresses we get to use. And the serial. Oops, I'm not in the configuration mode. That wouldn't have worked. Let's try again. IP route 209.165.200.240. My tab completion wasn't completed there. 255.255.255.240. Serial tab completion works. Good, I'm in the right mode. Okay, that should take care of our raw IP addresses. Now let's go and take care of DHCP and get these PC1 and PC2 working. Okay, so now if we look at PC1, it's got that temporary address, the 169.254, is a Class B address bank that Microsoft generously donated to the world to use for this function, that if a DHCP configured workstation like PC1 and 2 can't find the DHCP server, it's only going to be an R2. We haven't put it in yet. Then they'll assume a temporary address just so they have some limited connectivity on the network. Okay, so let's go back and make that DHCP function work on R2 and then see if we can get the our PC1, PC2 to get their addresses. I'm going to go ahead and go to, let's see here. I got to jump back to my lab on my screen so I can see the lines. So I've gone through and I've done task 1, preparing the network. I've done some basic configuration of the routers. I did task 3, which is configure PC1 and 2 to be a DHCP client. Now, I'm going to, on task 4, this is page 4 of your lab, I'm going to configure the DHCP server code on here. So I'm going to go to R2, and then we're going to see this mistake they put in the lab procedure in a minute. This is visible. Okay. All right. So task 4, step 1, before you create the DHCP pools, what we're going to do is specify the addresses we don't want the DHCP server to hand out addresses to. So in this case, they're using a common example of let's exclude 10 addresses from 1 to 10. So I'll go to the global configuration mode, and I'll say IP DHCP excluded address 192.168.10.1 through 192.168.10.10. And that'll take care of the FA00, use the .10, 10.1 address. Now let's do the same thing for 11.1 through 192.168.11.10. And that'll take care of the second thing. Now we can actually configure the pool. So IP DHCP pool, and he gives a number here of R1 for fast Ethernet 0. Oops. R1 fast Ethernet 0. Mostly caps. Prompt changes to the DHCP config, and now let's specify the stuff for fast Ethernet 0. And that's the network 192.168.10.0 with the 255.255.250/24/7. So that tells the DHCP pool function that look for any interfaces on this network, on this router that are at the 10.0. We have the 10.1 for our fast Ethernet /00. And he'll start sending the DHCP, looking for DHCP client server requests to be satisfied on that particular port. Now, let's give the DNS, the default router. I'm going to do it slightly out of order. Default router, that, of course, is the default gateway for all those guys. In this case, PC1. You should be granted an address of a default router, 192.168.10.1. Now, there is no DNS server in this network, but we're going to go ahead just for practice. We're going to configure the DNS value. So I'm going to type DNS server, and I'm going to put that Quad 9 project, which is I really think that's a great DNS server to use. You know, you are allowed to, you have to use DHCP for your cable modem network or your home network to get the address from your cable company. But you can go into the bottom part of the network control panel on Windows, and you can statically specify a DNS server. You don't have to use theirs. So you can leave the top one, click obtain the IP address automatically. And then on the bottom one, just click static DNS address, and you can put in your 9.9.9.9 there. Okay, that should take care of the DHCP function for the FA0 port. Now let's take care of the function for the PC2. He's connected to the second port, FA0/1. So we've already done the excluded address for both of these guys, so we can go straight into the configuration mode and do an IP DHCP pool, and his pool is R1 FA1. That's the unique names. What's our network for that? 192.168.11.0, 255.255.255.0. And the default gateway is that FA01's IP address. 192.168.11.1 is the default gateway for all the guys on the same network as at PC2. And just for practice, DNS server 9.9.9.9.9. We should be able to test this with ipconfig/all on our simulated workstation and make it work. So let's go to our PCs. Oh, we didn't do the helper address yet. So when we go to our PCs, we're going to go to PC1 and notice that he still is the 169.254. PC2 is still the 169.254. So the DHCP function on R2 is a broadcast function, and it cannot survive the trip. It goes down to R1, and it never goes any further. So we're going to fix that problem. We're going to go to R1 and we're going to go to R1 and we're going to put a helper address on those two Ethernet ports, and that's going to convert the broadcast into a unicast that can go through many routers and be helped. So I'll click on R1. Go to the configuration mode, go to interface F0, and the command is IP helper address 10.1.1.2. What the heck is 10.1.1.2? Why, that's the serial port. That's our entrance into the R2, which is the DHCP server we just configured. Now I'm going to go to interface F0/1, and his IP helper, let me see if I can, and his address is also 10.1.1.2. Okay, we've configured some stuff now, and we probably should be able to get some DHCP action. Let's load over here and see. Okay, what I'm going to do now is, oh, let me check. We were having a problem with our routing tables. Let's go back and check on R1. And just do a show IP route table. So he's seeing the 1.1.1.0 network. We can ping 192.168.20.1, which is our default gateway. We should be able to ping the 192.168.60. What the heck was that address for that server? 254. Okay, we have good connectivity there. So let me see. I'm going to go back to PC1, bring him down in the picture. Desktop, go to IP configuration. Oh, look, it worked. It worked. See, he's got the 10.11 address. He's got the 10.1 address. He's got the DNS server address. So if we go back to the real sort of pseudo desktop here, if we type ipconfig, he's got the 192.168.10.11 address on PC1. Remember, we excluded 10.1 through 10.10, so he got the next available address, which was 10.11. And can he ping his default gateway, 192.168.10.1? Oh, that's bad magic. How could DHCP probably give him the address if he can't ping? Okay, well, let's just press on this. Everything's going very well. He actually was given that address. Oh, I want to check one more thing. Go ahead and type out. Let's type ipconfig /all. And we can see that he's been given the 192.168. Did I fat finger in these numbers? 192.168.10.11. His default gateway is 10.1. It's got the proper subnet mask. He's got the right DNS server address. The DHCP server is 10.1.1.2. So all that looks good. We got some network connectivity here. I don't know if this is a firewall issue or what that we're not seeing this. Let's check and see what's going on with PC2. Just for fun here. I always like it when there's pop up because it's fun to try to compare. Oh, he's not getting anything right. Remember we had a problem with 11 not showing up? Okay, so let's look at R1. I'm going to do a show IP interface brief. 92.168.10.1, 192.168.11.1. Did I show protocol? Did I mess up any subnet masks? Oh, let's look good. So is it possible for R1 to ping 192.168.10.11? That's fine. So we have some weird issue with it. Fortunately, we only need to be able to ping from this one PC. Now, the PC, go back to PC1, which is the one that's working. We only need, fortunately in the lab, he only used PC1 to check the thing. So I can ping my default gateway 192.168.10.1. Now let's check the routing. Should I be able to ping 192.168.11.1? I'm just fine. Can I ping the server? believe it was 192.168.20.254. And this time. Okay, we're going to get mean and nasty here. Can I ping the 209.165.200.225? I can ping my outbound port. I'm going to get really crazy here. This didn't work either when I tried it earlier in packet tracing, but the NAT hasn't been implemented yet. Okay, not too bad here. A little problem with PC2 in his network, even though all the show commands look good. I'm going to chalk it up to packet tracer monkey business shenanigans. Okay, I'm going to scroll down in the lab here, and I'm going to start you on this NAT stuff, and I'm going to show you a little. Oh, wait a minute. Oh, wait a minute. We're not finished with DHCP yet. There was a problem with DHCP. He says in step 6 of router R2, there's a mistake in the lab. It says, here we are back at R2. In the lab, it says to type the command show IP DHCP binding from R1. R1's not a DHCP server. It's R2. You have to tap that on R2. So we see a binding here. The next thing he says is show IP DHCP pool, and that show of addresses and everything will be sent out. Now, that statement, debug IP DHCP server events, is not implemented in the packet tracer. That won't work. Now, later on, when you do the NAT code, there's a debug IP NAT. That works. That works in packet tracer just fine. So we can't see this. Okay, in task 5, you were doing the static and dynamic routing. I did that earlier. Now let's do this. I'm going to go to task 6. And if you look down and read to the end of task 7, it says you could have simply configured the overload statement in 6. Where does he say that? I'm looking for that. Okay, I'm on page 7 of the lab. I'm going to do task 6. I'm going to configure static NAT on R2. We're still on R2? Yeah, we're still on R2. Okay, good. And the trick here, and this worked okay yesterday when I tried it with packet tracer, this worked fine. I was able to ping from the ISP. I was able to ping the file server, not by his private inside address, but rather by his NAT address that we gave him. So in task 6, we're instructed to go to R2 and create this static mapping. Static mapping is what we usually use when we have a file server, a web server, a mail server of some sort in the inside of our enterprise, and we want it to appear to the outside world. But as a NAT address to whatever range of addresses that we're getting as globally unique IP addresses from our service provider. So this statement is given, first of all, to be in the configuration mode. And it's IP, NAT, inside, source, static. The server is 192.168.20.254. This is this company's file server. In the case of Tarrant College, it maybe could be our web advisor server or something of that nature. And that address should appear to the outside world as 209.165.200. Okay, that's the command to establish the relationship between the inside address and what address to translate it to the outside address and what to translate it back to when it comes back from the outside world. Now we have to specify what port on our router is the outside port to the outside world and what port is our inside trusted. So I'm going to say interface serial 0/0/1. That's my connection to the ISP. That's my untrusted connection. I have no control over the internet. So I'm going to say IP NAT outside. Now I'm going to go to my inside port, which was interface F00, and say IP NAT inside. They do give you the option in this lab of using a loopback interface instead of an Ethernet interface and dragging another machine into there, but I use the actual machine. So if this works, okay, Here's the big test here. We're going to go to the ISP. I'll go to the privilege exec mode, and I should be able, should I be able to? I was able to earlier when I tried this. 192.165.200.254. It worked. It pinged. Oh, thank you so much. So that worked just fine. Now, let me show you this debug IP NAT function on R2. I'm going to do this again, and we're going to see on R2 that some debug action has occurred. This is actually as implemented. It works okay. So I'm going to go to R2. The regular debug IP NAT. Turn it on. Now I'm going to go back to that ISP router and repeat this function. R2, look, we got some NAT. Well, let me expand this out a little bit. So we got some NAT functions taking place. The source address was translated into the inside private address, and you have connectivity with that guy. Okay, good, it's working fine. A little bit of word about NAT is, about debug, is when you finish using debug, turn it back off. On a production machine, it really eats a lot of the resources of the router that should be devoted to actually choosing the best path for packets to be routed. So I'm going to do, there's two commands, no debug all or undebug. Either one of them do the same thing. It turns on all debug. Under no circumstances should you type debug all. That'll fill up your screen with garbage and you'll have a hard trouble getting your router back. That's it. And I've heard that debug survives reboots. So be careful with that. Now there was a hint in the lab that said that you could use the NAT overload command from task 8 and task 7 and maybe sub yourself from doing step 8. So if you go to the bottom of, let me find it again. Where was it? Where the heck was it? I must have dreamed it. I can't find it right now. So you don't have to do task 8 if you don't want to. Task 9, document the network, that's at the end of the lab. That's the actual final ILS run listings. If for some reason you decided you wanted to experiment around with OSPF configuration, you could use these lines of code here and make it run with OSPF. I changed it to RIP because we haven't covered OSPF yet. So I suggest you use RIP now because that's what we want to. If you want to go out on a limb there and try OSPF, you can do that if you want to. Okay, let me see. So we had some hardware problem with PC2, even though it appears to be connected properly. So I'm happy that I was able to show you the RIP is working, the static routes are working, the NAT function to the inside server is working okay. I'm going to leave that last step to you guys as an exercise for the student. And let me see if I've forgotten anything here. I'm going to switch back to our plan for the day. Okay, so I got you started quite a bit today, more than I usually would, because this is a kind of a weird setup. I showed you how to use the 1841 built-in router from the folder that has the server ports, serial ports in it, so you don't have to provision them. We talked about at page 6 of the lab, task report step 6. He tells you to go to R1 and type show IP DHCP binding. It won't work. R1's not the DHCP server. He's just helper addresses. So you have to go to R2 to do that. If you go to R1, he won't have nothing. The debug IP DHCP server events does not work in packet tracer. However, the debug IP NAT does work, and I showed that to you. You should be able to use that. Okay, guys, I'm ready to wrap it up here. Again, the upper administration has requested us to ask you kindly, if you don't mind, please evaluate your classes. It's totally anonymous. Nobody can see your individual responses, and not even the teachers can see anything until after the grades have been turned in. So do that if you feel like doing that. Would be great, and it will show up on the, so that future students look at these classes, they can compare teachers and see what their evaluations were. I think you get to rate people on a 1 to 4 scale. And you can also put in events. So if you don't like my choice of bath soap, you can say, he stinks. You can do that if you want to. Now, the other evaluation, the student satisfaction survey that you are actually strictly required to complete is on the Cisco Network and Academy. With their 10 million students, they'd like to track their demographics, and you have to complete the course feedback form for the course before you're allowed to take the final examination. I've turned on those course feedback forms on. So if you go into assignments on the Network Academy site, NetAcad, and look for something that says course feedback form, you can complete that. But that's also anonymous. I can't see any individual user. I cannot identify individual users. I just get a sort of a composite result of all that stuff. And you're also allowed there to do a freeform text entry besides all the, they'll ask you questions like, how motivated are you to go get your CCNA certificate after taking the Cisco Network and Academy type courses? Do you feel this probably is going to help you prepare to get a job in the IT business? You know, stuff like this. So Cisco can gather demographics. Okay, one last check here on attendance. I think I've got everybody that show up. On a couple people here that normally show up, I'm not seeing, but I'm thinking they probably have connection problems. But no one will be penalized because of that. And this is being recorded so that you'll be able to view through and do this later when you go to the MyTC Blackboard for this particular course. Look for recorded presentations, which is right above the Blackboard Collaborate live sessions. And you can see the YouTube videos I posted of all my sessions there. Okay, I'm gonna mute my microphone, hang around a couple seconds if any guys got any chat requests, and that'll be it for today. Thank you. Looking forward to seeing you guys again next week.